Okay, now we will see how to plot a simple function using Python. In plotting functions, we need a module called Matplotlib to plot the function. So we can use this command to import Matplotlib. Import matplotlib.pyplot has PLT. So PLT is a short form for a Matplotlib, and this PLT can be used to use the commands like plt.plot ty. This will plot the variables t and y. So for understanding a plotting, you should know how the function is plotted. So any function which is y is equal to sine of x, which has a dependent variable and independent variable. X is called independent variable, and the function determines how it is dependent on x and how y is created. Okay, which means y is a dependent variable here. Okay, that's why. So if you plotting this to a plot, there is an x label which determines your independent variable. Y is always your dependent variable, and this is a particular plot here. That function determines the shape of this curve. And if you are looking at a simple plot, it should have the following features, which is one is called a title. We should give the title of the plot, and we should leave what is x is represented by x label and y is represented by y label, and we should have some legends which is showing sin x here. It's actually showing the function which is representing the plot, and which is particularly useful if you are using a multi-plot. Okay, if you are also plotting cos x, it is difficult to identify which plot is. So we can do some colors for this one, and identifying legends here to cos x, it is easily identifying that which plot it belongs. Okay, so if you are plotting a function, what you are doing is you will want to create an x axis first, whether you have to determine it is from 0 to 10 or etc. 0 to 10, you can create an x label with the how many points you require. Okay, if you are require more points, your number of points here should be much larger, which means the step size. Step size is the size between these 2 points. It should be large enough so that you can clearly see the figure. So the problem is that if you are reducing the number of points here, this point is not there, it should be a straight line. So you could not get a sine wave. That's why you should have to add maximum number of points to get a better curve. Okay, the first step is to determine what is the step size and what is the minimum point and maximum points of the x-axis. Then second step is to find your function corresponding this value. So all values in the x table, you can calculate the corresponding sine function, which means this is a dependent variable. Then the final step, you have to plot this one, and you have to give all these parameters like x label, y label, and title, etc. Okay, so this is the essence of the plotting a function. So this is a program to show a simple sine function. For this one, you need some type of modules. For NumPy, for the sine function, NumPy is there. We can import NumPy, and also linspace is particularly useful to determine your x-axis. And import Matplotlib pyplot as PLT, as already discussed, and NumPy is imported as NP. Okay, so first step is to create the x-axis, which is t is equal to linspace 0, 10, 1000, which means this is a minimum point or 0 point in the x-axis, and 10 is a maximum point. This is the number of steps you have to need it. If you are giving less points, your graph may not be clear, so it is better to put a larger number of points. Okay, then the next step is to plot creating a y-axis, which is np.sine t. For each value of t, you are creating your sine function. Then it is stored in the variable y. Next step is to plot plt.plot ty. Then the plot is generated. Okay, you get the plot now. Then the next step is to give the x label, plt.x label time. The time axis will be given. plt.y label, you get the amplitude here, and plt.legend sine t, you get the sine t as a legend. Then plt.title, plot of the sine function. And finally, you have to give a statement called plt.show to display your graph. So let's see in Spider. I have already written this program here. So that's the same program we have discussed is I have written here. And the next step, we have to run this program, and the plot is created. So if the plot is not coming here, you can search here. In the case of plots, you may see that figure there. So you get all the required things, and you get a nice plot. And this type of programs can be useful to demonstrate the different type of functions like cos x cube, and you can try yourself by demonstrating different type of functions.